Project Management for Healthcare Managers, Week 6, Project Planning. Quality Management, ACML 375. Quality is about the science and focus of delivering what the customer wants, delivering the results that satisfy the requirements of the customer, and driving to the specifications that are needed for the customer. Conformance to the requirements is vital to meet the end needs of the customer. Getting these customer requirements is often overlooked. The customer may ask for certain requirements, but if the voice of the customer is missed when starting the project, there is a danger that the result will not satisfy the actual need of the customer. The steps of quality are broken down into quality planning, quality assurance, and quality control. This section is focused on quality planning, which will form the basis for assurance and control. One of the ways to approach quality is to look at what is important to quality. What are the requirements that are needed by our customers, and how do we take care of those requirements? This is an approach that defines the requirements and then determines a way to measure those requirements so that you have the means to meet what the customer wants. To get this, you need to develop a target, a metric that identifies what the customer actually wants. Here's a model for the critical to quality approach. As an example, I've chosen a customer requirement, a good cup of coffee. There are a couple different requirements or characteristics that make a good cup of coffee. But the first quality that I want to describe is that good equals hot. So hot coffee equals a good cup of coffee. There may be more requirements, and there typically are in a project. But at this point, we'll focus on the example of hot. After we've identified the requirement or the characteristic that will satisfy a customer, good equals hot, we need to be able to measure it. What metric are we going to use? We're going to determine hot through temperature. There are a couple of different ways of measuring temperature. We'd use a thermometer to identify the temperature. We could also put our finger in the cup of coffee to determine if it's hot. We have to pull out our finger because it produces pain. Because of the heat, that might be considered a hot cup of coffee as well. To be sanitary and be more specific, we're going to use a thermometer rather than our finger. After we identified our metric and the method to measure it, we have to identify the target. This is done typically by asking or polling our customers to find out the best target, what their customers want the most. In this case, we have found through survey of our customers that the best hot is 140 degrees. That 140 degrees is the optimal temperature that's considered a good hot cup of coffee. Is it possible to get every single cup of coffee to exactly 140 degrees? After the survey, we verified the results with a sample set of customers and found the customers can't tell if the coffee is too cold or too hot if it's within a couple of degrees of our 140 degree temperature. Plus or minus 5 degrees is a tolerance level that they're willing to accept as being a good cup of coffee. So our range is from 145 degrees to 135 degrees to be an optimum heat for a cup of coffee. We have identified the elements that are critical to quality: our characteristic, our metric, our target, and our tolerance. More subjective methods of measurements may be harder to find, but follows the same methodology. Let's propose a good cup of coffee equals taste. This is a little harder to measure. If we take our quality characteristic of good equals tasty, what is our metric going to be? Our metric may not be an actual physical characteristic, but may be the result of a survey. A Likert scale is a range, or on a scale of 1 to 5, how good this tastes, with 5 being the best and 1 being the worst. If the Likert scale is our metric, the next step is to determine the target and the tolerance. We find that a good cup of coffee is at least a 4. But we also find that a 5 is also a good cup of coffee, and a 3.5 is a good cup of coffee. So we developed our tolerance around our scale as well. The approach is pretty consistent in defining our characteristic or requirements for the customer, what the metric will be used, and developing the target value and tolerance to determine what will be critical to quality. There are measurement characteristics that have an impact on how quality is measured. These characteristics are precision, accuracy, and customer satisfaction. The first concept is precision, which is the level of exactness. What scale you use to measure and the intervals that are used is important to being able to measure the outcome of the target. If you are trying to measure how long it takes to make a cup of coffee, and you measure the outcome in hours, the scale used is not precise, and you can't really tell if you're on target. You could measure the length of time it takes to get a cup of coffee in milliseconds, which would be too much precision. It would be better to measure in minutes or seconds. Accuracy is assessment of the correctness. How accurate is the measurement tool we're using? Let's go back to using our finger to determine a hot cup of coffee. Over time, your finger may get numb and not be able to tell if something's hot. A poorly calibrated tool is not accurate, and not being able to use the measuring device correctly leads to inaccurate measurements. If we want to have the right level of precision, we need to use the right scale. And to have accuracy, we need to make sure it works right. In quality management, customer satisfaction is the measurement and management of what the customer expects. A good quality management program includes objective criteria to manage the requirements of what the customer wants, as well as the fitness of use to meet the customer needs, so that the product satisfies the customer needs. One of the approaches to quality is prevention over inspection. This is an approach that Project Management Institutes holds as a valuable approach to project quality. And to prevent a mistake or keep a risk from happening is better than having to see it and correct it later on. There are two different ways to encourage prevention over inspection. One is poka-yoke, which is a Japanese term for mistake proofing. An example of poka-yoke is a polarized plug, where one of the prongs is slightly bigger than the other and will only fit into a plug a certain way. Visual controls are things that we can tell at a glance that something is wrong. If there is a flashing light that accompanies by an audible warning, this would be a visual control. For example, if our truck is too high when we approach a bridge with a low threshold, lights will flash and a siren will go off. Flashing lights, color coding, switches that change color when correctly attached are types of visual controls. The concept of prevention over inspection is that you prevent the error from happening in the first place, rather than having to detect it through inspection. When we're looking at quality management, we're looking for how to do continuous improvements through plan, do, check, and act. That approach is the identification of how to make improvements and then proposing and testing these improvements in a systematic way. In plan, do, check, act, if you have an improvement that needs to be made, you make plans as to what you're going to do, but you also are going to check the results before and after. Then you do the actual action, and you measure before you do, and then you measure after you do. You compare the measurements to make sure you actually made an improvement, that you've actually made a difference, and the results turn out the way that you want. If it does, then you act on that improvement. But if it doesn't turn out the way you want, A becomes adjust, and then you do plan, do, check, and adjust. Other measurements of quality besides target and tolerance of the critical to quality metrics is the cost benefit. How much benefit are we receiving from producing good materials? And what's our cost of quality? When we have poor quality, we have more non-conformance, which means more defects and more rework. Our defects are the products we have to throw away or rework. This means we're doing the effort twice and it's costing us more money. Another measurement of quality is the cost and benefit of doing an action, which is compared to the cost of rework's defect that occurs due to low quality. There are industry and statistical tools, and depending on the approach taken with the quality program, there might be a couple of different statistical or industry tools that are used. Benchmark is an industry tool that's used to compare against an outside source. It might be a company that does similar action, has a similar product, or a product and service in a different industry that's used to compare the quality output of the source company. Another statistical tool is DOE, Design of Experiment. This would be a way to systematically or scientifically look at the results and make variable changes to get better results. Statistical sampling is an approach where not everything is tested, but enough elements are verified so that you have the confidence in the entire population and the entire group. If testing takes a long time, or if it's destructive and part of the product gets destroyed, sampling is a great approach. These are some different approaches that might assist and be planned for during the quality planning stage. The output of a quality plan are those metrics that come out of critical to quality. A test plan is used to test the output and define that your metrics are being met. A final output might be a checklist, which are things you want to check off as you go through and complete your quality plan. To review, a good approach to determine quality or measuring quality is the critical to quality approach. This is where the output characteristic is defined, the measurement of the output characteristic is identified, and the target value and tolerance are specified. Quality outcomes are about precision, accuracy, and customer satisfaction. How much variance are you willing to take? And how on target does it need to be? Other measurements, such as prevention over inspection or continuous improvement. And then, what are those industry and statistical tools that help us out, such as design of experiment or benchmarking? Finally, the outputs from the quality management program, which include metrics, the test plan, and the checklist.